Alright, here we go. Today we're going to be discussing atoms. This is the first Vodcast of the ILS class for the 2013 school year. And what we're looking at today is we're starting off with our most fundamental part of chemistry. So what better place to start than with atoms? And so my little posing picture there. What do you think of when you think of atoms? I think here's my little thought box here. I think of either nuclear explosions with the atom bomb. There's my bomb. Or I think of the little, as you know, I'm the great artist, the classic picture of the protons, neutrons in the middle, and the electrons circling around the outside. So today what we're going to do is we're going to take a look at all of the structure of the atom, what's inside the atom, and the basic parts of the atom today. So let's first talk about what an atom is. Atoms are basically extremely tiny building blocks that make up everything around us, including yourself. You can almost think about them as kind of like very extremely small nanometer sized Legos. Atoms like to come together to make other molecules. They don't necessarily like to sit by themselves, so that's why they're like building blocks. Atoms are the smallest particle of an element that is still that element. And what I mean by that is that if I could take a hunk of gold and have a tool that I could chip away at it with, I could keep chipping past the point where there's no longer even visible to the human eye, and somehow this tool could keep breaking down that piece of gold until it's no longer gold. Well, then it's no longer gold and I broke through the atom, so that's not what I want. So the atom is the last possible point at which it was still gold. That would be the atom of a gold. So basically I have this little piece of gold right here. I could take this little tool and chisel it down until I get to this and get to the form of what the atom really is. The nice thing about atoms is they all have the same basic structure, meaning that all atoms are made up of protons, neutrons, and electrons. And a proton in an atom of oxygen is going to be the exact same as a proton in the atom of lead. There's no difference in the protons, just the number of protons. So it's not like there's special protons that go in all the different elements. There's protons, and each element is determined by how many protons are in that element. But we'll go into that a little bit more as we go through this today. We call these protons, neutrons, and electrons subatomic particles. If you remember from our prefix and suffix studies, you should know that sub means below. So these are less or below the level of atoms, and they make up the atoms. If you look at this picture, you can see the different subatomic particles also have different electromagnetic charges. If you look, you can barely see there's no charge here, a positive charge here, and a negative charge here. So we see there's different charges on the different subatomic particles. Protons have a positive charge, neutrons are neutral, have no charge, and electrons have a negative charge. You can also see there's a size difference. The electron, you can see, is a lot smaller here than, say, the proton or the neutron. The proton and the neutron are about the same size, but the electron is actually, you need 1,836 electrons to make up the size of one proton. So they are a lot smaller. Now what I want to do for you here, I'm going to draw up two different atoms, one of hydrogen and one of helium. It's no coincidence that these are the most simple elements that we can draw, and they're also the most abundant in the universe. If you remember, hydrogen is the main element that's inside of stars, and also helium. So let's take a look here. We need a nucleus and we need the electrons, and the nucleus is made up of protons and neutrons. And the hydrogen atom, you're only going to have one proton. I'm going to give that a positive charge there in the center, and then on the outside I would have an electron orbiting around. In a helium, this would be hydrogen, in a helium atom, I'm going to have 2 protons. And because I have 2 protons, I'm going to need 2 electrons to balance out the charges. Now I have 2 positives here, and that's kind of a problem. So we're going to put in 2 neutrons in the center also, and I'll get to why that's a problem in just a second. Why, just kind of think about this as we're going through this, why are we going to need the neutrons in here with these positive charges? There's a problem there if you think about some basic science that you've probably been over. This is a picture. I actually tried to do a video but it didn't work. I'm still trying to figure out this program, but this is a picture of 2 magnets, and what we have here, you have a negative charge here, and then you have a positive charge here. You have positive and negative, and I pushed these 2 together, and you can probably think of what happened. We had this was repelled backwards, and this is also repelled backwards. So we had these 2 charges as they get pushed at each other, because we should know though that like charges repel each other. So they get pushed back. So what you have in the nucleus of an atom, so what we have here with these charges, I'm going to get this out of here. Move these out of the way. If I were to have 2 protons together and they were just sitting together, what would happen? Well, these would be repelled apart. And so we have to have a neutron there. And what that is, that's called strong nuclear force. And basically what you have here, the neutrons are kind of like the glue of the nucleus of the atom. And so we have to have those neutrons in there to keep the protons from breaking apart because they have the same electrical charge. Atoms are all built in the same way, but the difference in the atoms dependent on the number of protons that are in it, and that changes what type of element it is. So hydrogen would have 1 proton in the center, helium would have 2, lithium would have 3, and so on. So the number of protons changes what the element is. The number of electrons has to be equal to the number of protons to have a balanced out electromagnetic force, because protons have a positive charge and electrons have a negative charge. So what you're seeing here is there has to be an equal force. If there's not, if there's more or less electrons, then that creates an ion of that element, and we'll get into that later in a different podcast. If there's a different amount of neutrons than there should be, then that creates what's called an isotope of the element, and we'll also get into that later. But let's just take a look at how a couple different elements are set up. So looking at what makes an atom different, I'm going to draw up 2 different elements for you here. I drew up hydrogen and helium for you. We're going to take a look at 2 other elements. We're going to take a look at carbon, and we're going to take a look at oxygen. And carbon and oxygen are both nonmetals. Carbon is a solid nonmetal, and oxygen, as you know, obviously is a colorless, odorless gas that we normally breathe in as the diatomic form, which is called O2, which is 2 oxygen atoms that have combined together to form a diatomic molecule. Anyway, we have 6 protons, so these are all our little positive charges here. And then we're going to have 6 neutrons also. And then we need to have 6 electrons. Now, we have those 6 neutrons, 6 electrons, 6 protons. We have these 6 protons and 6 electrons to balance out the electromagnetic charges. Again, we get into ions if we have too many or too little electrons. And if we would have too many protons, then we have a whole new element. The neutrons are in there again to hold it together. That's that strong force. We have, in the oxygen atom, we have 8 protons that make up oxygen. Well, a little bunch of plus signs here, a positive charge. And we're going to have 8, you need one more there, neutrons inside also. And if we have 8 protons, then we're also going to need, you guessed it, 8 electrons. Now, there's a reason I'm only putting 2 in the middle. We'll get into that eventually here, but not in this podcast. So again, what makes a different element is all in the number of protons. The last diagram is kind of misleading. Electrons would be a lot further out in a real diagram if you're actually looking at an accurate to scale diagram. If you're actually looking at a to scale diagram, the electrons would have to be a half a mile away from this dot here in the center. That's really incredible when you think about from this nucleus, they'd have to be a half mile out if that was the size of the nucleus. It's truly incredible to think that most of the atom is mainly empty space, and yet it appears solid to us, which we'll get into why that is further down the road. So here's your big finish of what we're talking about with atoms. And these are kind of the main points that you need to pull from this vodcast. All matter is made up of atoms. You, me, everything around us, the desks, whatever you're listening to this vodcast on is made up of atoms. Everything around us, the gas we're breathing, it's all atoms. Atoms are made up of subatomic particles called protons, neutrons, and electrons. And again, subatomic, once you break it down past the atom, then you get those little particles and you no longer have the atom. Nucleus of the atom is made up of protons and neutrons, and again, it's going to have an overall positive charge, and the electrons on the outside and moving around the nucleus, and they're going to have an overall negative charge. Atoms of elements are different due to the number of protons, not due to different types of protons or anything like that. And atoms are mostly empty space, with the electron moving very quickly, about 2,000 kilometers per second around the outside of the nucleus. That's all for today. If you want to check out some of those images I use, you can go to these sites. That's it for today's vodcast. If you have any questions about anything you watched or heard in this vodcast, please write it down, and we'll have a discussion about it in the next class period. And just keep that in mind as you're going through this second semester and also through the sciences ahead of you. That's the main idea of science, is to ask questions about the world around you. So never hesitate to ask questions and bring those into class. That's the best way to learn, and hopefully you think a little more critically as we go through these things and examine the world around you.